The moment of inertia of a thin ring or a hollow cylinder about a central axis or about an axis perpendicular to its plane passing through its center of mass is I equal to mr square. The axis of rotation is shown by the arrow, where m is the mass of the thin ring or the hollow cylinder and r is the radius of the cylinder. The moment of inertia of a thin ring about diameter as its axis of rotation, as shown by the arrow, is I equal to mr square by 2, where m is the mass of the thin ring and r is the radius of the thin ring. The moment of inertia of annular ring or thick-walled hollow cylinder about a central axis or about an axis perpendicular to its plane passing through its center of mass is I equal to half m r2 square plus r1 square, where m is the mass of the annular ring or thick-walled hollow cylinder and r1 is its inner radius and r2 is its outer radius. The moment of inertia of uniform disk or solid cylinder about a central axis or about a perpendicular axis passing through its mass or about a transverse axis is I equal to mr square by 2, where m is the mass of the disk or the solid cylinder, r is the radius of the disk or the solid cylinder. The moment of inertia of uniform disk about diameter as its axis of rotation is I equal to mr square by 4, where m is the mass of the uniform disk and r is the radius of the disk. The moment of inertia of a thin-walled hollow sphere about a central axis passing through its center of mass is I equal to 2 by 3 mr square, where m is the mass of the hollow sphere and r is the radius. The moment of inertia of a solid sphere about a central axis passing through its center of mass is I equal to 2 by 5 mr square, where m is the mass of the solid sphere and r is the radius of the solid sphere. The moment of inertia of a uniform symmetric spherical shell about a central axis passing through the center of mass is I equal to 2 by 5 m in the bracket r2 to the power 5 minus r1 to the power 5 bracket complete upon r2 cube minus r1 cube bracket complete, where r1 is the inner radius of the shell and r2 is the outer radius of the spherical shell. Capital M is the mass of the spherical shell. Moment of inertia of thin uniform rod or rectangular plate about an axis perpendicular to its length and passing through its center is I equal to 1 by 12 ml square, where m is the mass of the uniform rod or the rectangular plate and L is the length. The moment of inertia of thin uniform rod or a rectangular plate about an axis perpendicular to its length and passing through one of its end is I equal to mr square by 3, where m is the mass of the thin uniform rod or the rectangular plate and r is the length of the thin uniform rod or the rectangular plate. The moment of inertia of a uniform plate or rectangular parallelepiped about a central axis is I equal to m by 12 L square plus B square, where m is the mass of the uniform plate or the rectangular parallelepiped and L is the length and B is the breadth. Moment of inertia of uniform solid right circular cone about a central axis is I equal to 3 by 10 mr square, where m is the mass of the uniform solid right circular cone and r is the radius of the base disk. The moment of inertia of uniform hollow right circular cone about a central axis is I equal to mr square by 2, where m is the mass of the uniform hollow right circular cone and r is the radius of the base ring.